Okay, welcome to episode 11. I'm sure you have noticed that I've skipped question 10 or episode 10. The reason being that I haven't studied that question or that topic, and I don't want to mislead people or give false information. Okay, so but pressure, we are home and dry. So look at pressure, question 11. The question reads, Figure 11.1 and 11.2 show sections through very odd bicycle tires which are made of solid rubber. Okay, and the bicycle tire made of solid rubber. This one, figure 11.1, 11.2. Go to the first question. The first question reads, question A, the solid rubber in figure 11.1 exerts a pressure on the ground. Okay, define a Pascal. Okay, so what is a Pascal? A Pascal simply, you're going to do a quick one. What is a Pascal? Okay, Pascal. What is a Pascal? A Pascal. There you go. Let me just get my pointer. Okay, here we go. Okay. Okay, much better. Okay, let's explain. Get our pointer or our arrow. Okay, here we go. So a question it was saying that what is a Pascal? So a Pascal, this is 1 Newton, this is 1 Newton per square meter. A Pascal is just simply a unit for pressure. In other words, just define it in words. Or you can use the same formula here, put in bracket, but you have to put it in a bracket, not just leaving it like that. Because Pascal just have to define it. Okay, if a formula for pressure is pressure is equal to area. Is it force? Pressure is equal to force over area. Yeah, force over area. Here, hope you can see force over area. Now you have to define this in words. That's another way. Another way, that's way to phrase that question. Define this in words. So to define this in words, simply say, okay, this is 1 Newton per simply means the divide here. Discuss straight line per meter what? Squared. Because area is square is always measured in what? In meter squared. So this is one here. There's a big lesson you need to learn here, because when it comes to definitions in physics, you can actually use equations. Yeah, you can actually use equations to define something. For example, I can say, okay, acceleration is equals to what? Acceleration is equals to final velocity minus initial velocity over time taken. So in order for you to define acceleration using that formula, you can simply say, okay, acceleration is just a change or the difference between the change in velocity per time taken. That's how you can answer acceleration if you actually define acceleration. Same thing, just like that. That's how good that's the beauty of physics. Just need to know the formulas. After knowing the formulas, you need to understand, okay, if I see this kind of divide sign in the divide sign or this division sign, what do they mean? In English? Just it means pay. Then you're home and dry. You don't have to study all those just need to know the formula and use it in words and put it in words, and you have your 1 mark. That's how you get your 1 mark. Simple as that. Okay, good question. Question A2. Question reads, the mass of the bicycle and the rider is 60 kg. Okay, we're clear on that. And the total surface area in contact with the ground is 2.4 times 10 meters. That's the area. Supposed to be a square there, but I'm sure that I made a mistake without putting it. So the question continues. The gravitational field strength is 10 newtons per kg. Calculate the pressure exerted on the ground. Okay, we need to calculate the pressure exerted on the ground. So we know that pressure is equal to force over area. True, right? So here, go to the solving part. Okay, here we are. Get my pointer. Okay, we have been asked to find the pressure. Okay, so there, you notice that in the question we are given what? Kg, mass of what? Of the bike or the rider of that bike. You have been given the mass of the rider, which was 60 kg, but we have been asked to find what? Pressure. I'm not able to put the questions and the solution at the same time on the screen. I hope you have a paper. You can have a paper, or you can request, or you can contact me on my WhatsApp line and send you the past papers, so that when watching this video you may be reading the question and seeing how the solving is done. Yeah, so that's in the question we were given the mass of the rider, and we were asked to find what the pressure. Now we know that pressure is equal to force over area. True, indeed. But in the question they didn't give us what? The force. True as well, they didn't give us a force. So now how do we find the force? The force is just simply for the formula saying force is equal to mass times gravity is equal to what? Yeah, that's the formula for what? Force, mass times what? Gravity. Now the mass in the question we are given is what? It was what? Skist. They said that the bike had what? Weighed 60 kg. That was our what? That's where the skist came from. In another words, that's where the skist came from. Then the 10 is just the natural gravity of the earth. Wherever you go on earth, the gravity is what? 10. So you find the force, just multiply that kg by 10. In other words, for you to find force, just multiply the mass with the gravity of the earth. By vice versa as well, you can be given one quantity among these three, either force, mass, or gravity. You can be given gravity, you can be given mass, you can be given force, and they ask you to find one of them. But all you need to know that the formula for force is equal to mass times gravity. And what is our gravity? Our gravity is just 10, which is the normal standard of the earth, which is the gravity of the earth. And the mass of the bike ride, it was 60. Then you multiply it to give us what? 600 Newton. Then you go to the formula saying pressure is equal to force over area. Substituting in that equation, there was force, you put your 600 Newtons there, divide by the area. The area have been given in the question as well. After dividing, you should get this answer here, which is 200,000 here 250,000 per stands for Pascal, which is the units for pressure, and there you get your mark. I hope it's clear here. If you have any question, please leave it down on the comment sections. And I'm glad one of you commented that I should do the next one. I should do 2019, and without any waste of time, we'll do that immediately after this series is over. Okay, I go to the next question. Okay. Question 3. One of the solid rubber tires went over a small stone as shown in figure 11.2. Describe and explain how pressure exerted on the ground changes. Okay, the one of the tire here, this tire here went over a small stone, and explain how the pressure exerted on the ground changes. Okay. Sorry, let me just get my pointer. Okay, so I've been asked at how the pressure exerted on the ground changes. So the answer is that the pressure will increase because the area of the stone on which the tire exerted is smaller than the area of the tire on the ground. Now there's like a deep English here. There's a lot of scientific terms which is not clearly understood. So in simpler terms, simply means that for you to answer that question, you need to know that pressure is inversely proportional to what? To area. Meaning that if the surface is small, the pressure will what? Increase. If the surface is big, the pressure will what? Reduce. That's what we mean by inversely proportional. The best example I give in our daily lives is a needle. Yeah, a needle. A sewing needle. I hope you have seen a sewing needle. I don't have a picture of a sewing needle, but I'm sure at some point you came across a needle. A needle, you notice, for example, I can use the same arrow. This arrow I'm using here. At the edge here, where there's like a blue dot there, it's sharp. It's in short, it has a small surface area. Meaning that if I push this arrow here on the let me just use the needle example is better. If you want to use a needle, the reason why a needle pierces a surface is because it has what? A small surface. Why? Because the small surface exerts a large amount of what? Pressure. Yeah, a huge amount of pressure. That's why the needle is sharp to the small surface at the end. Why? You just need a small amount of pressure for you to burst or to pierce into an object or anything. You need a small amount of pressure. Why? Because it has a small surface at the end, like that. Pressure is what? Inversely proportional. The pressure will increase because area is inversely proportional to what? To pressure. Or in other words, you can simply say pressure will increase because the area of the stone on which the tire exerted is smaller than the area of the tire on the ground. Simple as that. If you've gotten the expression there, simply say area is inversely proportional to what? To pressure. Then you've answered the question. We'll go to question question B. Yeah, question B. Okay. Figure 11.3 shows a modern bicycle tire that contains air. True. A heavy person sits on the bicycle and the shape of the tire changes as shown in figure 11.4. So figure 11.3, figure 11.4, just like that. Okay, what do we have here? The table contains information about the tire in figure 11.3 and figure 11.4. Okay, so here in tire in figure 11.3 of pressure is 1.9 times 10 to the power 5, and tire in pressure in figure 11 point supposed to be 4, not 3 again. Here supposed to be 4. Excuse me, 11.4. Then you notice that here we've been given volume. We've been given the volume of figure 11.3, which is 0.01, 0.016. And been asked question B1, what is the volume of the air in the tire in figure 11.4, meaning this figure 11.4 there on your right side. So please don't cross multiply or don't choose direct proportion here. I know you'll be tempted to use direct proportion to answer this question, but you don't need to do that. Do that, the answer will be wrong. There's a law you need to follow, which law? The law says that volume 1 pressure 1 is equals to pressure 2 and volume 2. That is the law. In other words, that's a formula you need to use. Pressure 1 is equals to pressure 1 times the volume 1 is equals to pressure 2 times volume 2. So let's go to the X7 part here. Let me just get my pointer. Okay, like I said, the law says that here I went direct because volume, you can also find volume is equals to, like I said, there's a law here. It's a bit advanced. It's a bit advanced. The guy was making this pamphlet just went direct to the point, but you need proper explanation. If you don't know the law, you won't understand what's going on. You just be seeing numbers. So for you to understand what's going on here, you need to know that, okay, there's a law under pressure. Just forgotten the name of the law, but there's a law which says that P, pressure 1 times volume 1 is equals to what? Pressure 2 times volume 2. Now, in that table there in the question, we were given three things. Number 1, pressure 1, we were given. Volume 1, we were given. And also, volume pressure 2, we were also given. We were not given volume 1, volume 2. So now, for you to find volume 2, what you need to do is divide by pressure 2 on both sides. So that here, where there's pressure 2, that pressure 2 will cancel each other. And you divide this side by pressure 2 as well. We'll get this formula. That's how this formula came about. I do not have a drawing pad. I could have shown you properly, but I hope you get my explanation. The law which was used here is that P1 times V1 is equals to P2 times V2. Now, you have been given three quantities among those things, and one is missing. So what do? You make V2 the subject of a formula, and that's how you get this formula right here. So now, P1 have been given in the box, it was 1.9 times 10 to the power that. Then our V1 will be given this, what was this. Let's substitute in the formula now. Our volume 1, it was 0.016. Then pressure 2 are given is 2.1 times 10 to the power 5. When you do the calculation, you should be able to get this, round it off to 4 significant figures. You get this. Now remember the units, don't forget the units. The units always what? In cubic meters. Never forget the units. That the units is wrong, because we don't know what you're finding. You can be finding 10 bananas. Is it bananas? Is it oranges or what? Units are very important because it helps you to, it tells you what you're finding and what you're looking for. It helps you to be specific, because numbers can mean anything. So units are very important. And understanding the law that P1 times P1 times V1 times is P1 times V1 is equal to what? P2 times V2. That's the law which was used to find there. So now we go back to the question. Okay, the last question. This question reads, state one assumption that you made in arriving at your answer. Okay. An assumption. Let me get my pointer. Okay, one assumption which you can make is that volume will reduce since pressure has increased. Volume will reduce since pressure has increased. So this is also a law of pressure under pressure. Simply says that volume is inversely proportional to pressure. Okay, so this means that, for example, let me say high pressure increases when the number of particles colliding with the surface of the container or the walls of a container as pressure. So now, if you have a big container, you have a lot of space. In other words, you have a lot of what? Volume. When you have a lot of volume, particles won't be colliding with the walls of that container easily or very fast. Hence, pressure will reduce. But if you have a small volume or a small container, that container will have small space inside of it. Hence, the particles will be hitting the walls at a faster, at more often. In short, that's the best way I can say it. More often, the particles will be hitting the container more often. Hence, pressure will increase, but the volume will reduce. Why? If you use a big container, let me try drawing it here. Maybe it can work. Let's see. Okay. You have this container. Put on my drawings. I want to explain the law of volume is inversely proportional to pressure. So now you have this. The first one, volume is bigger. The volume. So you have these particles moving from there. This one dot. You have these my particles. Hope you can see. There. There's a lot of space in this container. As you can see, this is a can. Yeah, a can. You can simply say this is the can. You have a lot of what? A lot of space. Hence, this to my, let me just get my pointer. Okay. These to my small particles here. It will take time for them to hit this wall of what? Of the container. Hence, pressure will be small. The amount of pressure exerted won't be great. Why? Because there's a lot of space in that container. The containers and particles are not colliding with the walls of the container more often. So when the volume is increased, pressure will reduce. Why? Because the space between this particle and this wall here to also increase when you increase whatever volume. But let's say we reduce the volume. Let's see what happens when you reduce the volume of the container. Just need to erase this. Okay. Erase. Okay, like that. Okay, let's see if we have this kind of small container right here. Now, you bear witness that you've seen that the volume of the container has reduced. And the particles, this part, just like that. Okay. Like that. Let me get my pointer. Okay. Now you notice that here the spaces between the walls and the particles has reduced, meaning that the volume has reduced. But since the space here has reduced, or the distance between the particles and the walls has reduced, the particles will be hitting with the walls of a container more often compared when the volume was big, or when the container was big. Since the particles will be hitting the walls of the container more often, the pressure will increase in this container. Why? Because volume has reduced. Simple as that. That's what this statement means, that volume will reduce since pressure has increased. For pressure to increase, we know that the volume must reduce. That's how it means. So in other words, you can have the answers, but if you don't understand where the answers are coming from, it's a problem. You need to understand. You need to understand the topic properly. No wonder I've skipped question 10. Okay, we move on to the question 12. Question 12, finish this episode. Okay, we got to question 12. Question 12 reads, what is a wave? What is a wave? A wave, this is simply a transfer of energy from one place to another without let me say it properly. This is a disturbance. How can I say it properly? A wave. Okay, a wave. This is what a disturbance that transfers energy from one place to another without transferring any matter. A wave. This is a disturbance that transfers energy from one place to another without transferring any matter. If you're clear, a wave, this is a disturbance which carries energy from one place to another without transferring matter. Okay. What simply means that what they mean here, I'm sure it's straightforward there. This definition of a wave. The best example of a wave you can give is a water wave. When you have a water wave, energy will be transmitted. Let me just see. Do this. Okay, we need to be on the same page here. Okay. For example, this is a water wave, right? Like that. Yeah, this water wave. Once you miss the definition of the topic, the intro, the topic where you are going, you want to understand anything, you need to understand this first of all. So okay, you have this water wave, right? But then my drawings, but yeah, we're trying to improve on how we can represent our videos. We're working on that and well, but this is the best we can do for now. So as I was saying, this is water wave, right? And the definition is saying this is a disturbance which carries energy, meaning that here you notice that a water wave, when water wave is moving up and down, it will be in the same position. It won't move. This whole thing, this water won't move from here to here. Nope. It will be constant here. Why? Because no what without transferring any matter. No matter is moving, but what is moving? Energy. This what the waves are formed. That's why you can have huge amount of waves, but the water won't move. You can have for example, when you go to a beach there, the water will never go onto the shores. It will just be remaining there. But if you look at the far end or their horizon, you see that the water is moving, but the water is not moving onto the land, but the water there is moving. That's why it's called that energy. The water has energy, but its matter is not what is not being transferred. That scenario or that phenomenon that we call it a wave. A wave is just a disturbance. So you have these shapes here, but no matter should be transferred to any other place. That's what we call it a wave. Okay. We go to question B. Water waves are produced with a frequency of 4 Hz by hitting the water surface with a tip of a pen. If the wave travels 20 meters in 10 seconds, calculate what? The speed of the wave. Okay. Speed of a wave is equals to lambda times frequency. Yeah. Okay, well, you can use this general formula, but it's either ways to give you the same thing. Okay, let me just get my water. Okay, get my arrow. Okay, arrows here. Right there. Okay. So now I'll be asked to get the speed of the wave. Speed, we know that is equal to distance over time, and it said that it covered the distance of 20 meters. And how long did it take it? 10 meters. Just simply divide, and you have the 2 meters per second. That's how you answer that question. I'm sure there's no need to explain this formula, how it comes about. So it's straightforward. Okay, quick question B2. Question B2, where is it? Wavelength. Yeah. Wavelength. You need to understand this is a derive. This is just this. It was to find the speed of the wave. The one I said earlier, saying that speed is equals to what? Lambda times what? Frequency. So, like I said, okay. speed of the wave, v. Simply say v is equal to, okay, my drawings there don't work, so simply say v. Okay, I'm try using a different pen. Let's try this one. Don't work as well. Let's try using this one. It's a pencil. Don't work. Okay, I'll just explain it to you with my pointer. Okay, so how do we do it? Okay, we go. So we were saying that, okay, speed, the normal equation for speed of the wave is what? Speed is equals to wavelength times frequency. Now, in the question, we are asked to find the wavelength. So what we did is divide what? Frequency on both sides of the equation to cancel what? For short, you just have to make the wavelength subject of a formula. Hope it's clear. I wanted to try and doing this, because here, if I say this, you want to understand. You think that this is a normal equation, but this is what it has just been made into the what? Subject of a formula. Let's try this one. Okay. So we're saying that the speed of the wave is equal to what? It's equal to lambda. There's a symbol for lambda here. Without, we don't have a symbol for lambda. Okay, lambda. I will simply say WL, short for what? For wavelength. Okay, now boy, times what? Times frequency present by f. This is a value equation. So now for you, we have been asked to find what? The wavelength. So what do? You need to divide both sides of this equation. Let me just get my pen, my pointer. You need to, okay, let's do this. Okay. You need to divide both sides of this equation by wavelength. Here, divide by wavelength, here by wavelength. So that, not wavelength, sorry, frequency. Since we need to find wavelength, so we need to divide by both sides by frequency. Divide by frequency here, so this side frequency. So that when you this cancel this one, it means that wavelength is equal to what? Speed, which is v, over what? Frequency. This is a general formula, the base formula, which is where this formula came from. After substituting there, what you need to do is placing the speed you found, frequency there is 4, have been given in the question, and then you divide, you have 0.5 meters. That's how you find the wavelength. Let's go to question C. Do like a quick one. Question C. It's just we've been talking here. Question C, figure 12.1 shows a wave at a certain instant. The vertical arrows indicate the direction of the variation of some individual particles on the wave. Okay, draw the wave and use arrows to show the direction of the energy. Direction of the energy simply, this is what a transverse wave. So we know that transverse wave is always perpendicular there. So obviously, the direction of the wave to be direction of the wave, it will be direction of any flow of energy be this way. Why? Because this is a transverse wave. Then go to question. Direction in which the particles at x will move. Direction at which particle x will move. Okay. to move downwards. Hope you can see. To move downwards. I've stopped explaining because I'm trying to catch up with time. So I'll just be doing a quick one. The reason why this particle will move downwards, if you follow the flow of energy, it is going like this. Obviously, when you reach a peak, you have to go down again. That's how this direction of the particle will move. It's going downwards. Why? Because the energy is going like this. Up, down, up, and down. And I'm sure the next question is asking us to what? To indicate question wavelength. Draw the wavelength, of course. We know that. Let me just get my pointer. Okay. So how do you indicate wavelength? Okay, wavelength is simply one complete wave. For example, this is a distance wave. First, you have to define wavelength. What is wavelength? Wavelength is just the distance between two successive troughs or troughs. In other words, the distance between these two peaks here and the distance from here to here, so what call it a wave. You can only call it a successful trough or successful peak is because it has completed here, from here to here, there, so what a wavelength. The distance between this peak and this peak. If you want to define it, it's simply so the distance between two successful troughs. Troughs is just the maximum point where a wave reaches. The distance between maximum successful points where these two meets. Okay, go to the last question. Okay, in figure 12.1, which particle is in the same phase with X? You can choose either Y or Z. If clearly here you're able to see. Okay, get my pointer. To see that this point X, particle X and particle Y are in the same line, so you just pick one of Z or Y. They're in the same position, not position that, but in the same height. They're going in the same direction. This one's going down, it's going down. Why? Because they are supposed to going down. So going to question E. It says explain how the wave in figure 12.1 carries energy. Okay, so this is how. As the wave is escalating, the particles at right angles to the direction of the travel of the wave it carries its energy. Okay, thank you for watching Physics 54 Explained. Kindly subscribe and leave a comment on the topic you want us to teach or make a video on that topic, some topic under physics. Don't forget to subscribe. Thank you.